Hello there, and this is Alex recording your question here today. And we're going to start out with question number 14. So, at a retail store, there were 61 female employees. Well, we're just going to refer to this as NF for now. And it was found that their monthly income had a standard deviation of 194.40. And we're just going to call this SF. Now, the males, on the other hand, there was 121 of them, so we're going to call that NM, with a standard deviation of 269.92, and we're going to call that SM for now. The last sentence is, test the hypothesis that the standard deviation for monthly incomes is higher for male employees than it is for female employees. So, in a perfect world, the standard deviation for both the males and the females has to be equal. Now, this is something that I want you to take careful note of because everybody gets this wrong. There are two ways to write this particular statement. It's a matter of how you want to write it. But in this case, if I say the standard deviation of females should be equal to the standard deviation of males, then these two statements really don't have anything different about them, but it's how you write the second statement that matters. So if the standard deviation is higher for males, then you could say in your alternative hypothesis that the standard deviation for males is greater than that of the standard deviation for females, which means that men get paid variably higher or lower depending on what they do. But the other case scenario is that your females are going to be less than your males. If I can remember how to write an M. These two cases are significantly different, and these two cases differ on what kind of value you're looking for. Here you would be looking at a right tail test, which means you want a large F value for your test statistic. If you write it out this way, this means you want a small F value. And this has been a problem with students this semester. They don't understand the differences between these two statements because they think they're completely equal. That's not the way it works. You got to know which way you're writing this, because if you're writing it in this first case, which we're going to use first, you're definitely looking at something that's going to be a lot nicer to look at. So how can you manipulate your information so that way you can keep this consistent? What we need to look at is, what is a F test statistic? And an F test statistic is an S squared of your first data set over an S squared of your second data set, if I remember correctly. And based on what you sent me in your text message, you said you got a F value of 0.5187. That's because you probably made this your first group and this your second group. Order does matter here. So in other words, I'm going to keep this screen open just for a little bit. We're going to work towards the bottom because I don't get to work on multiple items here. So bear with me just for a minute. If we do it this way, your F test statistic is going to involve the let's see here, we want this to be larger. So larger number needs to go on top, 269.92 squared all over 194.40. And that's going to be squared. So I'm going to punch this into my calculator really quickly. 269.92 squared divided by 194.4 squared, and I don't have to worry about parentheses here. Aha, that's where the F of 1.92 comes into play, 1.92. However, though, the way you had it inputted, which was in this format, which is why all your answers was coming out really wonky, is because you did an F of 1.94, not 194. Alex, get it together. Come on, get rid of the 9. Bad computer program, you will obey. How about this? I just use a giant eraser. Sorry about that. One thing about working on newer technology is that you still got to work out some of the kinks. So 194.40 squared all over 269.92 squared. And if I punch that into my calculator, what do you get? The F equals 0.519 technically. So you really didn't do anything wrong, but you got to make sure that you got to stay consistent. And that means that there's two ways of specifically doing this problem, which means that there are two possible F values to this problem. However, because you did not keep track of your information and because you're not doing this by hand, you're not seeing the variations that could happen. You're just punching it all into a calculator and you're letting it fly. Not necessarily the best thing to do. So, that being the case, regardless of what you do though, the p-value is going to remain the same, and the p-value here was approximately, as you said, 0.0027. So what does this mean for you in the long run? Well, I'll tell you. In short, if I can remember, there we go. I want a new screen. Let me have a new screen. I forgot how to make a new screen in this. Come on. This one. Oh well. Point being is that you are going to reject your null hypothesis regardless. Unless you have a really, really small alpha value, which I highly doubt, you are going to reject the null hypothesis. Lines and text from the page. Yes. Shed drawings. But yeah, that's the point I wanted to make. So enjoy your night. I apologize for getting this to you really late, but again, I was really busy today, and I'll answer part number 15 in just a minute. But thank you. Let's see.